Again, the lesson today is called Proving that a Quadrilateral is a Parallelogram. We're not going to do a lot of proofs, but we're more just going to look at some more rules. I mean, yesterday, all of our theorems and everything, started with if a quadrilateral is a parallelogram, then. So they say if a quadrilateral is a parallelogram, then, and we looked at all kinds of different relationships and things like that. It's going to be kind of similar today, except the wording will be a little bit different, but a lot of the same ideas are going to come up. Skip ahead. The first theorem that we're looking at is the parallelogram opposite sides converse. So yesterday we looked at the parallelogram opposite sides theorem. Now we're looking at its converse. So it starts out, if both pairs of opposite sides of a quadrilateral are congruent. So if they just give us some shape, like we have in this picture. If they give us some shape, like in this picture, and they tell us that these opposite sides are congruent, then we can assume that the quadrilateral is a parallelogram. So knowing that those opposite sides are congruent is enough information for us to know that we have a parallelogram. What is a more, I'll say, traditional shape that is a parallelogram? Technically, yes. What came to mind for me was a rectangle, just because these two sides are congruent and these two sides are congruent, but they're not all congruent to each other. So it fits that picture a little bit more, but a square would be also a parallelogram. Square, rectangle, rhombus. Those would probably be the two that come to mind. So if you were looking at proofs a lot, like full proofs, you could see them giving you an image like this and saying, how do you know that this is a parallelogram? Or is this a parallelogram? And you would go through and you would say, AB is congruent to CD, AD is congruent to BC, and since it has two pairs of congruent sides, by theorem 7.7, this is a parallelogram. So hopefully we can kind of see how that would come together. On the other hand, I mean, if you would have looked at the notes yesterday, you probably would have seen that this was coming. We can say that we have a parallelogram if the opposite angles are also congruent. Again, you can see them giving us the picture, the top left picture, and asking us to prove whether or not it's a parallelogram. We could prove it by saying angle B is congruent to angle D, angle A is congruent to angle C, therefore by theorem 7.8 we have a parallelogram. We have questions on those first two? I don't think those are anything mind-blowing after what we talked about yesterday. I think we got an example. Yep. Find values for x and y, or for what values of x and y is the quadrilateral a parallelogram? So, I mean, it's kind of asking us to solve for x and to solve for y but just doing it in a little bit of a different way. It's saying what values do x and y need to be to make sure this is a quadrilateral. Whatever values we find for x and y, it needs to be such that SP is congruent to RQ and PQ is congruent to SR. So we need to make sure that those opposite sides are the same. How would we solve for x?
Put them equal to each other.
Yeah, we'll set them equal to each other. So we have 9 plus x equals 2x minus 1. X equals 10. I think. Yes. So x would have to equal 10. Now, how could we find y? How could we find y? Yeah, Jack?
Plug 10 into the x plus 7 and get 17, so we know that y has to equal 17.
Yep. Good. We know that this side and this side have to be congruent. So if we just use the x value that we found, we can find the right side and the right and left have to be the same. Now we have a corollary. Opposite sides of parallel congruence theorem. So if we have opposite sides, one pair of opposite sides of a quadrilateral are congruent and parallel, and the quadrilateral is a parallelogram. So they could not even tell us anything about this. This is different from the other ones because we haven't talked about parallel lines yet, right? Well, we haven't talked about it in the theorems yet today. But this is different from the other ones because we don't even know anything about CD or about AB. But if they tell us that those opposite, I mean it could be top and bottom or left and right, but if they tell us that they are congruent and parallel, then that is enough to say that the quadrilateral is a parallelogram. And it makes sense that they would have to be congruent and parallel, because we could have congruent lines. Lines that are the same length, but are facing each other like that. So then these top and bottom lines wouldn't be the same. So we wouldn't have a parallelogram. So they have to be congruent and parallel. This might be the, I mean, I know the ones so far have been really straightforward. This might be the, I don't know, most difficult one out of the theorems. But if I had to guess which one we would struggle with the most, it'd probably be this one. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Diagonals bisect each other, and the quadrilateral is a parallelogram. Hopefully you see how everything we talked about today is like the reverse or the I mean, it says on there the converse, but it's the opposite kind of what we looked at yesterday. Just having those diagonals bisect each other is enough to say that we have a parallelogram. Questions on any of those? I think we've got a couple examples. For what value of x quadrilateral parallelogram. So in order for this to be a parallelogram, they've already told us that CN and NE are congruent, so FN and ND would also have to be congruent in order for this to be a parallelogram. So just like we've done over and over again, we need to set these equal to each other. X would have to equal 4 in order for this to be a parallelogram. If X equals anything else, then FD wouldn't be congruent to ND. Now this is where a little bit more work, where we have a little bit more work. So if they give us a shape in the coordinate plane, and they want us to show that it is a parallelogram, how do we think we could do that? Well, there are actually a couple of different ways. What is one way that we could do that? Yeah, Kylie?
Find all the slope between them.
Yep, we would find each slope. What else would we have to find besides just the slope?
The length.
The length. So, method 1. Find slope and length. What else could we do? If we look back at those theorems, what else could we do? Could we do anything with angles? No, it's on the coordinate plane. We have no way of finding what the angles are. There's really, I think, only one more way that we could show that this is parallelogram. Which one? Yes, and that's the much easier way. That's 7.10. Talks about those diagonals. If we can prove that the diagonals, if we can prove that these diagonals bisect each other, then we're in good shape. Yep. We would be in pretty good shape. How do we show that each of these diagonals bisect each other? By the midpoint. Yeah. But the here, I'll add it further. No, I'll talk about it. Find midpoint of now, in this case, since it says show that it is a parallelogram, we need to find the midpoint of both diagonals. We couldn't just find the midpoint of one of them. By finding the midpoint of both diagonals and showing that the midpoint is the same, then that would show that they bisect each other. So if we find the midpoint, let's start with AC. The midpoint would be, let's see, add our x's together, so -3 plus 5 would be 2, divided by 2 is just 1. Add our y's together, 3 plus 2 is 5, divided by 2 is 5 over 2. So the midpoint has 1 and 2.5. Alright, we'll see if it's the same for the 0 plus 2 divided by 2 is 1. 0 plus 5. Yeah, it is. Sweet. So since they have the same midpoints, then we have enough information. Since the diagonals have the same midpoint, we have enough information to show that this is a parallelogram. How many people are going to want to use method 1? I hope you're lying. You can. If you want to, you can find the slope of each of those 4 lines and find the length of each one using what? What do we use to find length? Distance formula.
You just find the slope of each line, and like, let's say AD and BC are both
That's
-3, -3, which they are. So the slope of those lines is 1. And then the other two are 2, 5, and 2, 5.
You're saying
Wouldn't that mean it's a parallelogram already?
there's just the slopes aren't the same?
Yeah, I don't know.
You're not changing the distance. Like, you're not simplifying one of those.
It's all the slopes are the same.
I mean, it's kind of got
Yeah.
Well, let's look. Here are 5 ways that we can prove. Thank you, Brady. Here are 5 ways that we can prove a quadrilateral rule. It is a parallelogram. So we talked about 2 of them, but we can show that both pairs of opposite sides are parallel. So yeah, that's what you're talking about, right? Just showing that the sides are parallel, showing the slopes are the same. So that would work. We could show that both pairs of opposite sides are congruent, so we could find the distance formula for each of those 4 sides. Now, in what case would that be really easy? To show that both sides are congruent. When would that be really easy? Yeah. If we had a square, or if we had a rectangle, right? Showing that those slopes are the same, or that those sides are the same, that would just be counting boxes. So those would be times where maybe you want to do that instead of find the midpoint. Show that both pairs of opposite angles are congruent. Can we ever do that in the coordinate plane? No, we can't mess with angles in the coordinate plane. Show that one pair of opposite sides are congruent and parallel. That we could do. And that would be easy to do also with a square or a rectangle. Last one, show that the diagonals bisect each other. That's what we did in that last example. I think, personally, I think it's easier to find the midpoint than it is to use the distance formula. So if you guys, you guys can use whichever of those methods you like, but my go-to would be that last one, find each midpoint. Questions? Are we quiet because this is pretty easy? Or are we quiet because this is boring? Or quiet because it's easy and boring? Or quiet because it's difficult? That would work. Do I have another slide? How much time do we have?
Not enough for that.
You didn't just chill for the rest of the hour?
I agree with all of them.
No.
There's not many times I agree with all of them, but I agree with them.
I agree. I don't think we need to do the class game. Why don't you guys go to, it's on Big Ideas. I think it's like 18 questions.
Is that our assignment?
It is your